Hi everyone, today we're going to be talking about the counting principle. So if you want to write on the next clean page in your notebook, 8.2 counting principle, and we're going to determine the total possible outcomes. If you need to pause the video along the way, feel free to do so. My computer's been a little laggy today, so hopefully it won't be when I'm making this video. So what are outcomes? I need to know that before I can start. Outcomes are the different results that can happen. For example, if I'm tossing a coin, there are two possible outcomes. I could get heads or I could get tails. Those are my two outcomes. It's what can happen. So let's think about this. I'm going to go to lunch, and my choice of meals are I can have an entree and a side. My choices for entrees are cheeseburger, hamburger, and hot dog, and my choices for sides are fries or a salad. I should get the salad because that would be healthier for me, but I do like fries. So how many different meals can I choose from? Well, I could have a cheeseburger and fries. I could have a cheeseburger and a salad. I could have a hamburger and fries. I could have a hamburger and a salad. I could have a hot dog and fries. I could have a hot dog and salad. I could make a diagram that shows all of these choices, like a tree diagram. So I could go, okay, so for my entrees, I could have a cheeseburger. Oops, I don't want a yellow pen. Yellow is terrible to read. Cheeseburger. I could have a hot dog. And I could have a just regular hamburger. I'll just put a B for burger. So cheeseburger, hot dog, burger. Then with my cheeseburger, I could have a salad, or I could have fries. With my hot dog, I could have a salad, or I could have fries. And with my burger, I could have a salad, or I could have fries. This is called a tree diagram. So tree diagram shows all my different choices. Cheeseburger salad, cheeseburger fries, hot dog salad, hot dog fries, burger salad, burger fries. So I have a total of 6 possible meals to choose from, or 6 possible outcomes. So if I randomly selected one, I have 6 choices I could choose from. So tree diagram is a helpful way of doing this. Listing them is also a way you could do it, but I got to tell you, you're prone to make mistakes because you might miss an outcome, and it can be very time consuming. So there's this thing called the counting principle, and it says I can take my different choices I have. So my first one is my entree. That's my E. I'm going to put an E for entree. And then I have my sides. If I take my number of entrees, 1, 2, 3, and multiply it by my number of sides, in this case 2, I get 2 times 3, which is 6 possible combinations, or 6 possible outcomes. That's what the counting principle does. It gives you a mathematical way to determine your number of possible outcomes. So let's look at this one. I'm going to roll a number cube. And then I'm going to toss a coin. So I'm going to do 2 different things. My first one is going to be my number cube. My second one is going to be my tossing a coin. I'm going to put a C for coin. I'm going to put a D for dice so I can tell them apart. When I roll my number cube, how many different outcomes can I have? Well, I could roll a 1, I could roll a 2, I could roll a 3, I could roll a 4, I could roll a 5, I could roll a 6. So I have 6 possible outcomes. When I toss my coin, how many different outcomes can I have? I could have heads or I could have tails. So I have 2 possible outcomes for my coins. If If I multiply that together, I have a total of 12 possible outcomes. Okay, so let's think about that. What could I get? I could get a 1 heads, 1 tails, 2 heads, 2 tails, 3 heads, 3 tails, 4 heads, 4 tails, 5 head, 5 tails, 6 heads, 6 tails. Those are all my outcomes. There's 12 of them. I can then use this to determine my probabilities. So what would be my probability of first rolling a 3 and getting a heads? Well, when I listed all those just now, I had one choice that was a 3 and a heads. So there's only one way to make that combination. And how many different combinations did I have? 12. So my want of having 3 and heads, there's only one of those. My total is 12. How about my probability of evens and tails? Well, for my evens, I have 2, 4, and 6. So I have 2 different types of those. In tails, there's only one possible outcome. Oops, 2, 4, and 6, that's 3. And tails, there's only one type. Tails I can do with the coin. So I could get 2 tails, 3, 4 tails, and 6 tails. That's 3 choices I could make, 3 things that I would want if I wanted an even and a tail, out of my possible of 12. So 3 out of 12 is the same as 1 out of 4. So my probability of rolling an even number and getting tails on my coin toss is 1 out of 4. Okay, this is our definition of counting principle. If there are m ways, so like in our dice, that would be 6 ways for one choice, and n ways for our second choice. So in our coin toss, there's 2 options, heads or tails. The total possible outcomes is m times n. Okay, let's look at this next example. You're getting dressed. You have 4 shirts to choose from and 3 pairs of shorts. How many different outfits can you make? Well, we have 2 different choices we're making. We're doing shirts and shorts. So how many shirts do we have? We have 4. How many types of shorts do we have? 3. 3 times 4 is 12 outfits I can make. This is where my computer's lagging, you can tell. Okay, these are examples from our IXLs that we're going to be doing. We're going to be doing IXL II1. They're I's, not L's. II1. Called counting principle. And we're going to come up with how many outcomes we have. So Kara's ordering a birthday cake for a friend. There are 10 no, that's a 2. 2 cake flavors, 9 frosting flavors to choose from. How many different cakes can you have? Well, 2 cakes times 9 frosting will give me a total of 18 different combinations, so 18 different outcomes. Let's look at the next one. Liam's buying a new set of DJ equipment. He can afford 1 mixer, 1 turntable, and is trying to choose between 3 different mixers and 6 different turntables. But there are 4 different speaker setups he can also do. How many different sets can he have? Well, 3 mixers times 6 different turntables times 4 different speaker setups will give me a total of 72 sets. I probably should have talked about the speaker setups as part of this, things you can do also, but one is planning a day out for her grandmother's birthday. They're going to have lunch at one of our 4 favorite restaurants. We have 4 restaurants. Then they're going to go shopping at one of our 3 favorite stores. Then they're going to go to a movie. There are 3 movies out that you think grandma might like. So, how many different activities can they do? Well, 4 restaurants times 3 stores times 3 different movies for a total of 3 times 3 is 9 times 4 is 36 different outings they could pick between. And my last example, we have Samir. He is going camping. Trying to extend my page here. Oops, extended a little too far. He's going camping. There are 3 sleeping bags, 4 pillows, and 2 different types of tent, and 3 different types of tarps. So we're dealing with 4 different things. We have 3 sleeping bags, 4 pillows, 2 tents, and 3 tarps. So 3 times 4 times 2 times 3. Well, 3 times 4 is 12. 2 times 3 is 6. 12 times 6 is 72 different sets of camping gear you could make. Hope this makes sense to you. Have a fantastic day. Talk to you soon.